Hello dear friends, once again welcome you all back to Mass Transfer 1 course under the LMS initiative of the Department of Collegiate and Technical Education. So you all know that in the course we already have completed the first 5 units. So it is now time to take up the 6th unit which is titled as Drying. So we are going to learn about the drying operation in industries. So starting from its importance, we're going to discuss about its principles, and later on we are taking up some of the important drying equipments to understand their construction, working and applications. Okay, this is a course objective. So coming to the course outcome of drying operation. So a student after finishing studying this particular unit will be able to define various terms that are related to drying operation, then illustrate drying characteristics of a solid, then explain the mechanism of moisture movement within the solid, and also will be able to illustrate with sketches the construction and operation of various types of dryers that are used in industries. So that is our aim of teaching a student this particular unit. So, so this is a list of the contents of the present session. So today, since it's a starting session, we're going to learn about what is meant by drying, what are the principles involved in the operation, then what are the different purposes of carrying out the drying operation. Then we are going to learn a few definitions that are related to drying operation. So, like moisture content on wet and dry basis, and we also will have to learn the different terms called equilibrium moisture content, free moisture content, bound and unbound moisture. So then what is a constant and falling rate period, and also you need to learn what is meant by a critical moisture content. Okay, so let us start with the principles of drying. So what is drying? Drying refers to that operation which involves the removal of moisture of a wet substance by thermal means. That is, by using thermal energy, how the moisture from a wet substance is removed to make it dry. So that is all about drying operation. So it is that operation in which we see the removal of a small amount of water from usually a solid or nearly solid material. So where the transfer of the liquid, that is moisture, from the wet solid or wet substance in general into an unsaturated gas phase called as drying medium takes place. So there is a contact between the solid or the wet solid from which the moisture has to be removed and an unsaturated gas phase, means the gas phase which is unsaturated with respect to the moisture content. So that unsaturated gas phase used for drying the solids are called drying media. Okay. So that means in drying, a gas phase contacts a solid phase. So the drying medium is a gas phase, and the solid and the material to be dried is usually a solid phase, as I told you. So it is a gas to solid mass transfer operation, and the mass is transferred from solid to gas phase, and the heat is transferred from gas to solid phase. So that means drying is another operation in which both mass and heat transfer are important. So earlier in the second unit, we have seen humidification, which is also one of the mass transfer operation in which both drying and mass transfer and heat transfer occur simultaneously, and both influence one another. So this is another example. Okay, so this is what I meant. In drying, heat and mass transfer occurs simultaneously. Heat is transferred from the bulk of the gas phase, that is drying medium, which is usually hot air. So in most of the drying operations, hot air is used as the drying medium. So that represents the gas phase. So the heat is transferred from that gas phase to the solid phase, from which you have to remove the moisture. And in the same way, mass is transferred from the solid phase to the gas phase in the form of liquid and vapor through various resistances. So whenever moisture evaporates from a wet substance into the gas phase that is applying heat, so we say that there is a transfer of mass from the solid phase to gas phase. So this mass that is transferred is that of a liquid and vapor, and it has to diffuse through various resistances in order to get the substance dried in the operation. So the material that is usually a liquid, and in most cases it's the moisture, that is water in the form of moisture, and it is transferred from solid to gas phase, and that material is known as solute. And the reason for transfer of this moisture from the wet solid to gas phase is that the gas phase is always unsaturated with respect to the solute material. That means we are using a gas phase, so that has a capacity to acquire more amount of moisture in the form of vapor. So since that phase is unsaturated with respect to the water or the moisture content, then there is always a transfer of um, moisture from the wet solid or wet substance to the drying medium, that is gas phase, that is hot air. So in most of the drying operations, heat required to evaporate moisture is provided by hot air or any other gas. So that is the drying medium. Okay, so this is a simple flow diagram showing you so what a drying operation involves. So wet solid material is supposed to be brought to the dried condition. So one thing that takes place is the heat transfer into the wet material and supply of latent heat of vaporization of the moisture. So this amount of heat is required to evaporate the moisture present in the wet solid, and due to that the moisture evaporates and transfers from the wet solid to the gas phase, that is drying medium, and that is what is taking place as a second process, that is mass is transferred as the diffusion of water through the material to the evaporating surface takes place. So subsequently evaporation into the air also takes place after the moisture reaches the surface of the solid. So this is what is known as drying. Okay, so it's a simple figure showing you um, how we can remove the moisture from the wet material. So the sphere shown with the blue color is representing a wet solid. So the blue color is meant for indicating there is moisture that is present in the solid. So this moist product, when subjected to drying, that is by supplying heat energy, then the moisture present on the surface of the solid first gets evaporated and added to the air or the drying medium. So that is not the end of the operation. In fact, all the moisture up to equilibrium moisture, I'll tell you what is meant by equilibrium moisture later, present inside the solid also diffuses to the surface of the solid, and the evaporation subsequently take place. In that way, see, you can look at the difference between this and this diagram. The blue color that is shown inside has decreased in this part of the diagram, showing you that moisture that was initially inside the material has diffused to the surface and has been evaporated. Okay, so what the given material can be dried up to zero moisture content. So as you can see from the last figure, which is totally in orange color, indicating that the material that is being subjected to drying operation is completely brought to the dry condition. So there is no blue color, means it does not contain any more moisture. So this is the wet substance and this is the dry substance. To convert it to dry condition from wet condition, you are supposed to add heat energy. So that is how we can explain the drying operation in this diagram. As the removal of moisture by thermal means is more costly than by mechanical means such as filtration, the moisture content of the material must be reduced to minimum possible level by the latter means before the material is fed to the drying equipments. Okay, so drying may usually involves removal of small amount of water or moisture present in the wet substance. So that means since the drying requires the utilization of heat energy, the removal of moisture by this method is much more costlier compared to other methods like filtration. So filtration is also an operation where water from the solid material can be removed. So the moisture content of the material must be reduced to minimum possible level by the latter means, that is by using mechanical means before you feed the material to the drying equipment for removing the remaining traces of moisture by utilizing thermal energy. So it happens that drying is frequently the last step in a manufacturing process after evaporation, filtration, and crystallization. So these are three unit operations that usually precede drying operation. So before drying could take place in a manufacturing process, you can see evaporation, filtration, or crystallization. So and after that drying comes, and after drying is over, the material is ready for end use and it can be sent to the consumer from the industry. So the main purpose of drying operation is to obtain the products in a manufacturing process in almost a dried form. So that is the main reason. So why drying is required? It's because if the material is obtained as an end product in the solid form and also in the dried solid form, so crystallization converts the liquid product to solid product because the use of solid product is much more easier compared to liquid product. So anyhow, the crystallization will not give you 100% dry solid product, and that is achieved in a drying operation. So the crystals after getting separated from mother liquor will still be wet in condition because traces of mother liquor will be adhered to the surface of crystals. So if you want to use these crystals for further finishing operations, first you need to remove those traces of liquor present on the surface of crystals. So that is when the drying comes into picture in the sequence of manufacturing process. So drying operations are mostly encountered in these industries. It is an essential component of a manufacturing process in food industry and chemical industry agricultural industry, pharmaceutical, textile industry, etc. So why drying need to be carried out? So as I already told you, the handling of the dried solid material is much more easier than the semi-solid or wet material. Okay. So there are specific reasons why drying is to be carried out and why it is important. So one reason is to reduce the transport cost. So the transportation of solids is much easier compared to transportation of wet or sticky material. To remove solvent adhering to crystalline product after filtration or centrifugation. So this is what I just now explained in the previous slide. So the solvent adhering to the crystalline product need to be removed to get the crystalline product in the dried form. So that is when its quality is best. So you need to use drying operation for this purpose. For easy handling and storage of materials. So handling of dry solid product is much easier compared to that of wet or a liquid material. So it is that reason which emphasizes the need of drying operation in industry to meet market specifications in solid products. Specifications of solid products. The solid products from an industry have to meet some market specifications. Means they need to contain a specific amount of moisture. So in that condition, they are accepted in the market as a good product. So to meet such requirements or specifications for an end product in an operation, the solids need to be dried. So also whenever moisture is present in a material, it leads to corrosion problems. Means the deterioration of the material as well as corrosion of the vessels in which the product is stored, shipped, and used will be lesser if the moisture content is not there. So to reduce corrosion problems that result due to presence of moisture, we need to carry out drying operation. So for example, a chlorine gas is a product from a industry. So if the chlorine gas is wet, it is highly corrosive, but traces of moisture present in chlorine makes it highly corrosive. So this is where you need to understand the importance of drying operation. So provide definite properties to materials. Okay. So in certain dried condition, the materials, the products acquire certain properties. So to give that property to the material, the product has to be dried to the required extent of moisture content. So as an essential operation in the manufacturing process. For example, drying of paper in paper manufacture. So paper manufacture involves drying as an essential step in the manufacturing process because paper after its production and sizing has to be dried if it can be used as a end product. So without paper being dry condition, you cannot use it for any purpose. So this is an essential step in the manufacturing process of paper production. So like this, drying in some industries is a essential operation or essential step in the sequence. So the purposes of drying also varies from industry to industry. So here I'm just telling you or taken the pharmaceutical technology and food technology or food industry, pharmaceutical industry to make you understand the different purposes of drying. Okay, so these are the reasons why drying is important in a pharmaceutical industry. The first one, to avoid or eliminate moisture that may lead to corrosion and decrease the product or drug stability. So pharmaceutical products are very sensitive products. Okay, so its quality, means its property, should be very carefully maintained till its end use. So the drug has to be stable, and for that reason you need to get the product in dry condition. Also, the moisture, if it is present, the product will be corrosive in nature. So that is the main purpose of drying in pharmaceutical industry, to improve or keep good properties of the material. For example, flowability, compressibility. So the given product um, will have a right kind of flowability during its handling, and also compressibility if it is in dry condition. So that is a good property of a material which is obtained by drying operation. To reduce the cost of transportation of large volume of materials. So if a product is obtained in the form of liquid, then the transportation, so this we have already understood in the previous slide discussion. So the transportation of liquids is comparatively tougher, because we need to transport large volume of materials, and also the transportation of liquids is much difficult compared to the transportation of solids. So that is one of the important reason why drying is important in pharmaceutical industry. To make the material easy and more suitable for handling. So this is again a general purpose. So whichever material that you take up or consider, their handling will be easier whenever they are in properly dry condition. The final step in evaporation, filtration, crystallization. So whenever evaporation is present in a manufacturing process, then that is usually followed by filtration, and then crystallization, and then drying of the solid. So here the drying is the essential final step in these manufacturing processes. So these are the list of purposes of drying in a food industries. The first purpose is to avoid or eliminate moisture, which may lead to corrosion and decrease the product stability. So this is again similar to the first purpose of drying in the pharmaceutical industry, to improve or keep the good properties of material like flowability, compressibility, to reduce the cost of transportation of large volume of materials like liquids, to make the material easy or more suitable for handling, and a preservative method. So drying is a preservative method in case of food products. Then the final step whenever these unit operations are involved in a manufacturing process. So that is the importance of drying in industries. So let us now go through some of the definitions that are related to drying operation. So first one is moisture content on wet basis. So it is defined as the ratio of the weight of moisture to the weight of wet feed material. So if x kg moisture is present in 1 kg dry solids, then the total amount of dry solid is 1 plus x kg. So according to our definition, moisture content on wet basis is equal to 1 divided by x divided by 1 plus x. Okay. So then the moisture content on dry basis. Here we are representing the amount of moisture present in a given material with respect to the weight of dry solid. So it is defined as the weight of moisture to the weight of dry solids present in a wet feed material. So if the feed contains x kg moisture and 1 kg dry solids, then the amount of moisture per kg of dry solid is simply x. So that is x divided by 1, which is equal to x. So the moisture content on wet basis, sorry, there is a spelling mistake over here. the moisture content on wet basis equals x kg. So what is meant by constant drying conditions? So whenever a batch of material is dried in a suitable drying equipment, it is subjected to contact with the hot drying medium, that is usually hot air. And if the conditions used in the operation are such that the temperature, humidity, velocity, and the direction of flow of hot air or gas across the drying surface are constant. So usually the drying operation is carried out in a semi-batch fashion. The material to be dried will be kept inside the drying chamber, and the hot drying medium or drying gas will be made to circulate through the dryer. That is, it flows over the surface of the material that is being subjected to drying. So that flow of hot air, if it is with a constant velocity and in the direction, in a particular direction that is constant, and if the temperature and humidity of that drying medium is maintained constant, then the conditions of drying are called constant drying conditions. So equilibrium moisture content, which is denoted by x to the power of star, it is the moisture content of the substance that is in thermodynamic equilibrium with its vapor in the gas phase under specified humidity and temperature of hot gas or air. So this is termed as equilibrium moisture content. So whenever the solid that is getting dried comes to a state of thermodynamic equilibrium with its vapor that is present in the gas phase, that is drying medium, under the specified humidity and temperature of the hot gas or air, then the moisture content of the substance is called as equilibrium moisture content. So this is the amount of moisture that remains in the substance at equilibrium condition of the operation. So it is that moisture content of the substance which is in equilibrium with the given partial pressure of the vapor. So it represents the limiting moisture content to which a given material is dried under constant drying conditions. Excuse me for a mistake over here. I'll repeat the sentence correctly. It represents the limiting moisture content to which a given material can be dried under constant drying conditions. So this part has to be cancelled. Okay, can be dried under constant drying conditions. So that means this is the content moisture of the given substance up to which you can dry the given material under the given conditions in a drying operations. So that is what is meant by equilibrium moisture content. So the next definition is bound moisture content. So it is that moisture in a substance which exerts a vapor pressure less than that of pure liquid at the same temperature. So the moisture present in the substance that is present usually over the surface and in the voids, that is interstices or the gaps or pores, we can say, present in the solid, and that moisture actually exerts a vapor pressure. Okay, sorry, the moisture which is exerting vapor pressure less than that of the pure water at the same temperature is called as bound moisture content. Okay, so and that moisture which exerts a vapor pressure equal to that of pure liquid or pure water at the same temperature is called unbound moisture content. Okay, unbound moisture content is the one which is primarily held in the voids of the solids. Excuse me for the confusion. Okay, so the unbound moisture is that one which exerts the equilibrium vapor pressure equal to that of pure liquid, whereas the bound moisture is the one which exerts a vapor pressure less than that of the pure liquid at the same temperature. So unbound moisture is the one which is primarily held in the voids of the solids. So what is free moisture? Okay, whatever moisture that is present in a given substance that is in excess of the equilibrium moisture content is called as free moisture content. So free moisture content is that amount of moisture present in the wet material which can be removed under the given conditions by carrying out drying operation. So it is obtained by subtracting the initial moisture content of the feed with the equilibrium moisture content. So X minus X star will give you the free moisture content. So at a given temperature and humidity, it is that moisture of the material that can be removed by drying. It may include both bound and unbound moisture. So it is also important that the removal of bound moisture is difficult compared to the removal of unbound moisture. Okay. So this we will learn again in the next class, where we are going to discuss the equilibrium in a drying operation. Okay. So next definition, constant rate period. It is that part of a drying process during which the rate of drying expressed as the moisture evaporated per unit time per unit area of drying surface remains constant. So whenever a batch drying is carried out, up to certain period of drying, the rate of drying remains constant. So that period or time of drying is called as constant rate period. So the rate of drying is usually measured as the moisture, that is amount of moisture evaporated per unit time per unit area of the drying surface. So that rate remains constant during the constant rate period. It is a drying period during which the rate of drying is constant. Okay, so this is again what is meant by a free moisture. So free moisture is that moisture which is present in a quantity above the equilibrium moisture content. Also, the free moisture content is that moisture which can be removed by drying under the given percentage of relative humidity. So next comes the falling rate period. So as the name itself says, it is that period of the drying operation during which the rate of drying falls, means decreases with the moisture content. So it is that part of the drying process during which the rate of drying varies with time, and instantaneous rate expressed as the amount of moisture evaporated per unit time per unit area of drying surface continuously decreases. So it is a drying period during which instantaneous rate of drying continuously decreases. So this is how we can define a falling rate period in a simple way. So now comes one more definition, critical moisture content. So critical moisture content is that moisture content of the substance at which the constant rate period ends and the falling rate period starts. So just now we understood what is a constant rate period and what is a falling rate period. So first part of the drying process is the constant rate period, and the second part is the falling rate period. So the moisture content, when it gets reduced to a certain extent at which the constant rate period ends and the falling rate period starts, is known as critical moisture content. So that critical moisture content is a function of constant drying rate as well as material properties and particle size. Okay. So this diagram shows you the various stages of drying in a moist solid. So here in the figure A, you can see that the substance is completely wet in condition. So this is the starting stages of drying operation. You can see the shaded area representing the moisture present. So these are the grains of the solid which is to be dried. So now there is presence of moisture in all the sections of the solid. So after the gas has contacted the drying for a certain period of time, you can see that most of the moisture present on the surface of the solid that is exposed to drying medium has been evaporated. So this part of the material has become dry. So in the third figure you can see that the amount of or the moisture that is present in the voids between the particles of the solid has disappeared, means it is indicating that that moisture that was initially present in that space has moved towards the surface, and from the surface it has evaporated into the drying gas. Okay, so figure A shows where the solid is uniformly wet. Figure B shows the solid with the upper region partly dry, and the figure C shows the solid where the upper region of the solid is completely dry. So the resistance to moisture diffusion increases from figure A to figure C, and the drying rate decreases. So here in this part of the drying process, the drying rate will be constant, and as the moisture in the upper part decreases, the remaining amount of moisture from the wet solid has to be evaporated by diffusion of the moisture from inside to the surface. So that is the reason why the drying rate decreases in the later stages of drying operation. So in this figure, the vertical arrows indicate the diffusion or the movement of moisture from inside the solid to its surface, and from the surface towards the to the inside of the drying medium. Okay, so that completes the first session of drying operation. So I hope I have succeeded in helping you understand all the concepts that we discussed in today's class. So we discussed about principles of drying, in which we understood what is drying operation. So we also learned what are the different reasons why a drying operation is carried out, and also we understood the various terms of drying operation or the definitions of drying operation. So let us check our understanding now by answering these MCQs. The first question, the vapor pressure exerted by the moisture contained in a wet solid depends upon the nature of the moisture, temperature, nature of the solid, all of these. Okay, so in fact, the what quantity of vapor pressure that is exerted by moisture present in the wet material depends upon all these factors. So option D is the right answer. So if moisture content of the solid on dry basis is X, then the same on wet basis is. So we have seen in the definition that the moisture content on wet basis is X divided by 1 plus X. So option A is the right answer. So moisture content of the substance when at equilibrium with the given partial pressure of the vapor is called as, is it free moisture, is it unbound moisture, is it equilibrium moisture, is it bound moisture? So I hope all of you have given the right answer. So let me give you the right answer now. It is option C, the equilibrium moisture. Moisture in a substance exerting an equilibrium vapor pressure less than that of pure liquid at the same temperature is called as, is it bound moisture, is it unbound moisture, is it critical moisture, is it none of the above options? So we know that it is the bound moisture which exerts a vapor pressure less than that of the pure liquid at the same temperature. So first option, that is option A, is the right choice for answering this question. So drying of wet solid under constant drying conditions means exposure of the wet solid to the air of constant humidity, velocity, temperature, all of this. So I hope you guessed the right answer. It is the option D, which says that the constant humidity, constant velocity, and constant temperature are maintained in a constant drying conditions. So in drying operation, the moisture that is evaporated is the equilibrium moisture, free moisture, bound moisture, unbound moisture. Okay, so think over and give me the right answer. I hope all of you have guessed the right answer. It is the free moisture that is usually removed in a drying operation. Moisture in a substance exerting an equilibrium vapor pressure equal to that of pure liquid at the same temperature is called, is it unbound moisture? Is it critical moisture? Is it free moisture? Is it bound moisture? Okay. So in the previous slide, we answered a question where the moisture that exerts a vapor pressure less than that of the pure liquid is the bound moisture. Okay. So the last option is a wrong choice. And also it is not the free moisture, because free moisture may include bound as well as unbound moisture. And it is also not the critical moisture, because critical moisture is the moisture content when the constant rate period ends and the falling rate period starts. So the right option is option A. So thank you for listening to me. So this is the end of the first session on drying. So in the next class, we are going to learn more definitions on drying operation along with the equilibrium stage in a drying operation. So thank you again. So see you again in the second session.